So let's keep going. So now we have our basic decision tree learning algorithm. We know how to do the recursion. We know how to stop. We have at least two good candidates to use for an evaluation measure. Just the error rate, which is quick and simple, and the information gain, which is a little bit better. Okay? But now we need to start getting closer to the real world. Right? The algorithm that we saw here by itself is still not that good for most things. Okay? When Quinlan did his decision tree work, initially he was just trying to predict the outcomes of chess games. And he did a very good job of that. In chess games, there's no noise, it's all discrete data, right? It was very nice. And then this stuff that he did motivated by playing chess, now these days is used to mine everything in the world, right? So this is how science happens. You develop something for one thing, and then it gets used for completely different things, like say, clickstream mining, which is what you're going to do in your project. Okay. So, but now let's start looking at generalizations of this. And the first one is, well, what if my attributes are not Boolean, right? So let's say first that my attributes are still discrete, but have multiple values. So for example, I could have the color of my object with 3 or 4 different values. Or, here's one that's very important for marketers. I could have your zip code, right? A zip code is an extremely predictive feature of the things that you buy. And there's a lot of them, right? A zip code doesn't just have 2 or 3 values. It has in the thousands or tens of thousands. Okay? So what might we do then, right? So the algorithm that we have so far is for Boolean attributes. What do we do with attributes with multiple values that are still discrete? Any suggestions? I have a suggestion, which is you can read the slide. But I have a better suggestion, which is don't read the slide and come up with it by yourself. So what might you do?
N-ary trees instead of binary.
Pardon me?
Multiple children of...
Yeah, exactly. So the most obvious idea is, well, let me just split on every value, right? I compute the information gain, right? I compute the new entropy at each value. I do the average, and that's my split, right? So I have an attribute with 10 values, and that creates a decision tree with 10 branches. Okay? This is a perfectly good thing to use a lot of the time, particularly if your attribute doesn't have a lot of values. Right? Let's say color has 3 values. Which model car do you like? Which color? Well, there aren't that many colors, but zip code might be kind of tough. For 2 reasons. One is that, well, there's going to be a lot of splits there, right? Also, it runs the danger of overfitting, as we'll look at a little bit more shortly, right? So there is certainly one option is you just construct a multi-way split. But what's something else that you could do, right? So one of the problems with doing this is that maybe the distinction between some of those values is important, but the other ones aren't. Right? Let's say you're trying to sell yachts, right? You probably want a zip codes of affluent people. But whether you're in the zip code of middle class, lower middle class, working class, whatever, that doesn't matter. None of those people are going to buy yachts anyway. So when you split on all values of the zip code, you're making much finer distinctions than you want. Okay? So what else might you do? This is also one that you really want to know about because often it's what you really want to use. No, of course, you can choose a different attribute, and good answer, right? But as far as this attribute, let's suppose that all your attributes have a lot of values, right? What would you do, right? Or among, what could you do with this one attribute, right? You can split on all the values, but what is something else that you can do?
You can group them.
Yeah, exactly, you can group the values. I can say, well, let me group all the wealthy zip codes together and all the others together and split on that, right? This is actually the third option here. This can work very well. The problem, of course, is that you have to figure out what the groups are. If the attribute doesn't have a lot of values, you could try them all, but this is going to be exponential. So for something like zip code, this would not work very well. Okay? You would need some other way to try to pick what are the good ones. Okay? So there's a third strategy, which is just pick one value and test that against the others. Right? Are you in, Beverly Hills? If you're in Beverly Hills, we want to sell you a yacht. If you're anywhere else, for the moment, we don't. Right? So we split on that value. Right? If you think about it, if I have an attribute with 100 values, that's really just having 100 Boolean attributes, right? Is it equal to the first value? Is it equal to the second value? So effectively what I can do is I can convert the multi-valued attributes into a bunch of Boolean attributes and then test on those. Okay? And so I split off Beverly Hills, and maybe next time I go to Medina, right? Medina is a good zip code for selling yachts, and so on. That's probably better than splitting on all of them at once or trying to somehow guess, what the wealthy zip codes are. Okay? Questions about this? Okay, so that's features with multiple discrete values. Now, what do you do if you have real valid features? And again, there's a lot of different things that you could do here, but what's a simple one that we in fact already touched on? Actually, let me give you a hint, right? One of the ways that we had of handling, that we just saw handling multi-valid features, was turn them into a bunch of Boolean features, right? Can we do something similar with numeric features? How might we do that? Let's say I have my temperature scale, right? The temperature could be anywhere from below freezing to scorching hot, right? So what can I do?
Range.
Yeah, I can form a range. Or as we saw before, I can do this one piece at a time, which is look at thresholds. I can say, is my temperature greater than 60 or not? Okay? Temperature greater than 60 is a Boolean attribute, right? So what I can do is that I just form a threshold that every value that I have in the data, if I don't have a lot of data, right, some subset of the values, right? It doesn't have to be too fine. And now I'm back in the situation where I have a bunch of Boolean attributes. And then maybe I can decide, well, if the temperature is higher than 60, we will play tennis. If it's not, then let me test some other things. Okay? So this is the simplest way of handling continuous attributes. Navigational warning, if you do this on large data sets, this will be very, very slow because there's a lot of values. So, you might want to do something more refined. But on data sets that are not too large, actually just doing this will actually be fine. Okay? Questions?
So basically, we start with most deterministic and don't forget about the negative case, then we have feedback loop to just update that. That's how
we repeat, right? So what we're doing here is reducing these more complicated cases to the simple one that we already have. Right? So for example, in the case of a continuous attribute, I can test the temperature at one threshold. It's a Boolean test. Later, I can come back to it and say, well, but now if the humidity is very high, then maybe at this point I care about the temperature again. In fact, this is how you build a little staircase to approximate the diagonal frontier, right? You keep alternating between testing X and testing Y. This is actually how you wind up with that staircase. Okay. More questions? Okay.